Hi, and welcome to your Writing Chemical Equations podcast. In this podcast, we're going to go over how to take a word equation and convert that into chemical symbols and eventually balance that equation so that you've written a proper chemical equation. All right, so the first step in writing a chemical equation is to take those words in the problem and convert them to chemical symbols. You want to do this in the same order that they're presented in your word problem. Keep in mind that elements don't need subscripts if they're all by themselves unless they are diatomic, which we talked about on the last podcast. That's your Brinkelhoff. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine all are going to need that little 2 subscript after the fact. Let's see. If they're by themselves. Otherwise, you'll look to what they're bonded with or look at the name of the formula in order to figure out what the subscripts are. You're going to use the charges on ionic compounds to determine what the subscript should be. The goal is to create neutral compounds. You're going to use prefixes on the names of covalent compounds to determine your subscript for covalent compounds. And then finally, you are going to use an arrow to separate your reactants from your products. You'll use a plus sign to separate reactant from reactant, or product from product. This was a bad example, sorry. And finally, your last step, once you have neutral compounds, once you've written all the symbols out, once you've identified if you have diatomic elements, the final step is to balance, to make sure that you have the same number of atoms of each element on the reactant side as you do on the product side. All right, so let's go through this word equation and we'll go through the steps that we were given. So the first step is to take these words and convert them to chemical symbols. So I see copper 2 carbonate forming copper 2 oxide and carbon dioxide. So I'm going to start with this first compound that I see, and that is copper, and the symbol for copper is Cu. It's a transition metal. I don't know what the charge is, but thankfully it has Roman numerals that tell us the charge is a +2 because metals are always positive. Carbonate, I see the AT ending. That tells me it's a polyatomic ion. It's CO3 with a 2- charge. Okay, well, I know that when the charges are opposite but equal, I don't have to write any subscript because those are in a 1-to-1 ratio to each other. So I'm going to write that down here. Cu, CO3, that's calcium carbonate. The word forming is going to be code word for an arrow. So this is the only reactant in this particular equation, and that happens sometimes. So if you ever see forming or reacts to form or makes or synthesizes, those are all keywords that you need to include an arrow right after that. Again, remember, I am writing these in order of the word problem. All right, so the next thing they tell us is that copper 2 oxide. That's another compound I'm going to have to write. Symbol for copper is Cu, and they tell me that it's a +2 charge still. And oxide is oxygen, which has a 2- charge. Again, we have opposite but equal charges, so I don't have to write any subscript because they're in a 1-to-1 ratio to each other. So I'm going to write that down here, CuO. All right, next I see the word and. And is code for plus, which means we have 2 products that are made, and the way we separate 2 products is by putting a plus sign. All right, and the last thing I'm seeing up here is carbon dioxide. I see that prefix that's telling me that it's a covalent compound, and I'm going to use those prefixes to determine what my subscript should be. So carbon is C, and there's no prefix before. So that tells me that I only have one of those because I can't write the word mono on the first element. Oxide is oxygen, and the word di tells me, or the prefix di tells me I have 2 oxygens. So now I have my chemical formula. I have neutral compounds. I check the charges on all my ionics. I use the prefixes to determine my subscript for my covalents. I've written in the arrow symbols, although not well. That does not look like an arrow. I assure you that is totally an arrow. And I've also added my plus signs to separate products from each other or reactants from each other if that's applicable. My last step is to balance this equation. So as I always do, I'm going to draw that line separating my reactants from my products. And the first element is copper. I see that there is no subscript, so there's 1 copper on this side. And on the product side, I also see that we have 1. Fabulous, that was easy. Moving on to carbon. I have 1 carbon on this side. Okay, notice that this 3 is hanging off the end of oxygen. That means I have 3 oxygens. Doesn't mean I have 3 carbons. You would need parentheses around both of those elements in order for the 3 to apply to everything, and it doesn't. So on my product side, I also have 1 carbon. Oh my gosh, I have 1 to 1. This is wonderful. I don't have to do anything. My last element is oxygen, and I have 3 oxygens on this side according to my subscript. And going over here, I got something kind of funky going on. I've got 1 oxygen here, and I've got 2 over there. Well, being that they're both oxygens, we're going to add all of those oxygens together and see what we get. So here I have 1 oxygen plus 2 oxygens gives me a total of 3 oxygens. Oh, these are my favorite. We do not have to write any coefficients for this to be balanced. It's already done.